You know, when you get a really complex piece of equipment, it comes with this mountain of paperwork, right? And it's so easy to just assume everything's okay. Well, today, we're not talking theory. We are opening a real-world case file. This is the story of how a routine document check caught a disaster waiting to happen.
And that really is the central question we all need to start asking. Because that test report, it's not just some formality you file away. It's a critical safety document. And you know what's funny? Sometimes the most important clue isn't what's in the report, it's what's missing. So, let's meet the subject of our investigation. We're talking about a massive 10-megawatt motor. Just to give you an idea of the scale here, that's literally enough power to run a small town. So yeah, this is not just another piece of machinery, this is a serious high-value asset.
And where was this beast headed? To a petrochemical plant. Now, this is a place where safety and reliability aren't just goals, they are absolute, non-negotiable requirements. The margin for error is and has to be zero. Because, you see, when you put the wrong piece of equipment in an environment like that, you're not just risking a mechanical failure, you're setting the stage for a potential catastrophe. This investigation stopped that from happening. Let's dig into how they did it. All right, so when you're looking at any piece of equipment, you have to start with what I call the triangle of documents. This is your foundation, your core evidence. And the number one rule is that these three documents have to tell the exact same story. No ifs, ands, or buts. It's a really simple workflow. First, you've got the specification sheet, the spec. That's what you asked for, what you paid for. Then, you have the inspection and test plan, the ITP. Think of this as the manufacturer's signed promise of what they're going to test. And finally, number 3, the test report. This is the final reality, how the equipment actually performed. And in our case, the problem started right here, when the reality didn't match the request. So we started cross-referencing these documents, really treating it like a detective story. And almost immediately, big red flags started popping up. Key tests that were explicitly requested in our spec, were just gone, completely absent from the final report. The gaps in that report were frankly alarming. A noise test? Missing. The full torque curve, which shows the motor's power at every speed, it was incomplete. But the biggest red flag, the one that really got our attention, was the missing vibration test. You see, vibration is the silent killer of rotating machinery. It just quietly causes wear, fatigue, and eventually total failure. But in this specific case, its absence pointed to something way, way worse. And this is the moment the investigation shifted gears. It went from being a simple contractual issue to a full-blown critical safety emergency. Because we weren't just missing some performance data, we were missing the one thing that made this motor safe to even turn on. Buried deep in the original spec was this one little line. A Zone 2 hazardous area is an environment where an explosive gas atmosphere could form. This changes absolutely everything. You can't just put a standard motor in there, it becomes a potential ignition source. So you see, for a motor that's going into an environment like this, all those performance tests, they're secondary. The number one priority, the single document that trumps every other piece of paper was the explosion-proof certificate. And it was missing. Gone. Without that certificate, we're talking about something like an ATEX or IECX certification. This 10-megawatt motor was, for all intents and purposes, a bomb. Installing it would have been an act of gross negligence. This was the smoking gun. Now, finding these kinds of issues means you have to understand what these technical tests are actually telling you. So let's crack the code on some of this jargon so you can spot these problems for yourself. Okay, locked rotor torque. Sounds complicated, but it's really simple. It's the raw, brute force starting power of the motor. The best analogy is a weightlifter needing that initial burst of pure strength to get a heavy barbell off the ground. If your motor is trying to start, say, a conveyor belt loaded with rocks, it needs a ton of locked rotor torque, or it's just going to stall and burn out. Next up, no load current. This is basically how much energy the motor uses just to spin itself, with absolutely nothing attached. It's exactly like a car's fuel consumption while it's idling in neutral. If that number is high, it's a huge red flag. It means there's too much internal friction, probably from bad bearings or sloppy assembly. It's a direct reflection of the manufacturing quality. Then there's the heat run test. This is an endurance trial. You run the motor at 100% power for hours on end just to see if its temperature level's off. It proves whether the cooling system can actually keep up with the heat being generated at full load. This is a marathon, not a sprint, and you have to know if your motor is going to overheat 20 miles in.
And now let's circle all the way back to that missing vibration test. Think about the wobble you feel in a car's steering wheel when the tires are out of balance. In a motor, that same wobble creates friction and wear. But in an explosion-proof motor, that same vibration can cause moving parts to touch each other, creating a spark. And as we now know, in a Zone 2 environment, one spark is all it takes.
So what's the big takeaway here? What does this all mean for you? It means you have to adopt a new mandate. A test report is not an archived document to be filed. It is an active, safety and operational guarantee that you have to personally verify.
So here's your checklist. First, always cross-reference that triangle: spec, ITP, and test report. They have to match. Second, question every missing test, especially if it's labeled special. Third, if the equipment is for a hazardous area, you must demand that ATEX or IEC-KEX certificate. It is absolutely non-negotiable. And finally, treat that report like the critical safety document it is. In our case study, a formal letter was sent demanding the missing certificate and tests, and thankfully that resolved the issue before the motor ever even left the factory.
So, I'll just leave you with this one thought. The most dangerous flaws aren't the ones you find. They're the ones you never even thought to look for. So, go back and take a look. What might be hiding in your last test?